Okay, so let's pretend we're just sitting around in our living room, and we see this problem. N dogs start at the corner of a regular N-gon. Each runs directly toward the dog on its left. How far do they run before colliding? And we're thinking to ourselves, gosh, how am I even going to think about this problem?
It says maybe it says how far do they run, so maybe you could calculate the distance from them to the center.
Okay.
Well,
But even before that, even before you started calculating, like what do you think you would want to do?
Well, because this says for an N-gun, so this leads me to believe it's the same for every N-gun with the same side lengths.
Okay, interesting.
So like we could look at a triangle.
Oh, not a bad idea at all. Let's look at a simple case.
and it doesn't say what their side lengths even are.
That's true.
But it only says they're regular, so that side lengths have to be the same length.
Yeah, so there's a triangle. So that's an interesting way to start. By the way, is that the simplest N-gun?
Well,
What about
this a two-gon really isn't a shape. It's a line.
Yeah, what would happen with a two-gon, by
Well,
the way? What would happen
they'd
with this
run.
problem?
Well, they'd run at each other and collide in the center.
Interesting. Okay, so we can understand the two-gon situation actually pretty easily.
Yeah.
Can you figure out how far they ran in the two-gon?
Well, exactly half of the line.
Good. So the two-gon, even though it seems like a case that's actually just even too simple, or what you said, it's not even really a polygon, but at least that one we can understand what's going on.
Oh, we can move up.
Now, with a three-gon, which is sometimes called what?
A triangle.
A triangle, yeah.
So they all run toward the center.
Well, no, they all run towards the dog on the left. So they definitely don't all run straight towards the center. Actually, do you think you could like take a marker and draw the path that you think one of these
So
is going to follow? In fact, let's make a bigger triangle so we're not struggling with the marker. Okay, so we'll try to make a big a big equilateral triangle. Who wants to attempt to draw it first?
Okay.
Okay. All right. So why don't you try to guess where this person runs, and this person is going to run initially towards that person up there,
Well,
or that dog. So
can they change direction during the?
absolutely, they're always running directly. This one's always running directly towards that one, wherever this one is.
Well, so it starts at going here,
Yeah.
and then they all, since it's threefold symmetry, they all do this. And then they see that this guy is running, this guy is here, so they start running maybe like down toward him.
Okay. Where does that guy start running?
here.
This guy runs at him,
Okay.
and this guy runs at him.
So it looks like it's sort of spiraling inward.
And then, so this guy realizes that he's over here now. And he goes over here. This guy goes here. And this guy goes here.
Okay. And now what
And then
happens?
they keep running into each other until they collide. Like, this guy runs this guy runs here, this guy runs here.
Wouldn't it depend on like the width of the dogs?
Yeah, I think what we'll do is just pretend they're dot dogs. But you're right. If they weren't dots, it would depend on the width.
So the lengths, we could try to measure like maybe the length
Okay.
of these.
Yeah. It's pretty
And
interesting.
they keep going inward.
Yeah.
So eventually they get so insignificant that they don't really matter.
Now, let me ask you this question. We figured out for a two-gon that they run halfway. So each one of them would run this far on a two-gon, right? If we make a triangle that has exactly the same side lengths as that, what do you think? Do you think they run further when they're set up in a triangle or when they're set up in a two-gon?
Well, I think they run. Well, actually, they might run the same. Well, it would be exactly half of the line. This is for a two-gon.
Yeah? And just looking at your picture, do you think the triangle dogs run farther, or do they run exactly the same
I
distance?
think they run farther because you have more of these line segments.
But they're smaller lines.
They're smaller. Maybe it's like that 1.5, 1/4, 1/8 problem. Does it go to 1?
Interesting. Yeah, that's actually very interesting. Well, one way we could estimate it actually is we could pretend that this triangle has a side length of 2.
2. 2.
2. And so each one of them runs 1, right?
Yeah.
For a two-gon.
For a 2. And then for a triangle, we said they meet in the center. And so we should just try to figure out where that center is and like how far away is it from the original point. Because if it's more than 1 away from the original point, then they definitely would have run farther.
Well, I sort of see a way you could calculate this using more complicated shapes.
Oh yeah?
So an n, it says an n-gon, so you can use any n. If you use infinite n, you get a circle, and the distance would be the radius.
Oh, very interesting idea. Let's see what happens on a circle.
Okay.
Okay?